So what I'm going to talk about is IntelIâå containers. This is a 20-minute session. If you're interested in more details, we also have a booth in the expo hall where you can actually try it live. So first, just before going into IntelIâå containers, for most people, when they talk about containers, there are two aspects to containers. One is the containerization, how you package your applications, how do you deploy them, how do you scale them, what kind of orchestrator you choose to use, like Swarm. So that's what most people associate with containers. That's the benefit of containers. Very efficient, with a very good way to package, and a very easy way to deploy and also scale it up. There's the second aspect to containers. When you run a workload in a container, how is that isolation achieved between on two containers running on the same machine on the same VM? So typically, if you use the standard run-C implementation that comes with the Docker, that is achieved using Linux namespaces and C groups. And beyond that, if you really care about security, you would apply some kind of security policies, be they Linux policies or seccom filters that are particular to your workload. So you need to craft custom policies on a workload by workload basis to achieve separation between containers running on the same host. So that's the reason why most people who deploy containers in a multi-tenant environment tend to deploy containers inside virtual machines. So you get separation between containers across tenants by creating virtual machines that are tenant specific, and you run a tenant's container inside virtual machines. So you are already paying the penalty of virtualization, even though you're running containers, but you're getting the other benefits of containerization. So this is just a quick high-level overview of what a namespaced container looks like, right? So all containers running on a VM or a host share a common host kernel, and your application, all applications on that given host use the same kernel. What that means is if there is any kind of vulnerability in that particular kernel, it has the potential to either compromise the host or other containers on that same host. And more importantly, once you gain control of the host, you pretty much have control of the network layer and everything else. So that's the reason most people run containers in VMs. So there are a lot of benefits to containers. We think that security is an issue still, and what we're trying to address with IntelIâå containers is give people an option to run workloads in IntelIâå containers for better security. So now very quickly, what are IntelIâå containers? What IntelIâå containers gives you is whenever you launch a container and the runtime on that machine is a IntelIâå container-based runtime, instead of launching that container using run-C, we launch that container using an OCI compatible runtime, which we call the IntelIâå container runtime. So that effectively launches each container in its own lightweight virtual machine. So every container now runs transparently in its own virtual machine, but you can still use all the Docker tooling that you're used to. You can use the standard CNM network plugins. You can use your volume drivers. You can do secrets management. You can use Docker Swarm. Only thing is the isolation for the work between workloads is enforced using extremely lightweight VMs. So this gives you the potential to not have to run containers inside virtual machine just because you don't know what the workload could be doing. So it gives you an option to do bare metal container deployments, and in some cases even bare metal multi-tenant container deployments. So this will give you higher densities. Also, it gives you higher security than it gives you higher density than running containers in VMs. It gives you better security than running containers bare metal. So it's it's a choice you make. You get slightly lower performance, slightly, the scaling level is not as high as bare metal containers, but you get something in between. So what is clear containers based on? The clear containers is based on we support any and all distributions. So all we need on the host system is a recent version of KVM. We package as part of clear containers and highly optimized version of QEMU, which we call QEMU Lite, which comes with a special platform called PC Lite. PC Lite is just enough platform to run a container. It doesn't have any legacy devices. It doesn't require a BIOS or firmware. So all you have is a kernel, which is again a very minimal optimized kernel, both for memory footprint as well as for boot up performance. And we package a minimal OS that is enough to bootstrap the container workload. So what this ends up, and also we use a lot of features that have been introduced both in QEMU and KVM over the years. Things like kernel same page mapping, virtual non-volatile memory, DAX-based file systems mapping to achieve much higher densities than on traditional VMs. So if you look from a traditional VM's point of view, clear containers is the leanest and fastest virtual machine you can build that can launch a container. But we chose not to expose it as a virtual machine, but to expose it as a container so that you can use it seamlessly using the container tooling. And it's completely invisible to you. So you might be wondering, how fast are these clear containers, right? I thought I'll do a quick demo. So in this case, on this machine, I've installed clear containers as the default runtime for Docker-D. What this means is on this machine, if you launch a container, it gets launched as a clear container. Also on the same machine, you can continue to launch traditional containers. So on a container by container basis, you can choose which runtime do you want to use. I've just set the default runtime to be clear container runtime. So let me just launch just a regular Nginx container using clear containers. So anyway, so that's it. It comes up, it boots up, it ran in a VM. We have compared the latency associated with how long the container gets available to you on the network. So if you compare against a RunC container, we take around 150 milliseconds more to reach it versus being able to reach a regular container. But in the bigger scheme of things, when you're doing orchestration in a Docker Swarm, that 120 milliseconds extra really doesn't add up to something that is visible to you at that layer. And just to show that here, you can just reach the Nginx container just like that. If you use your Docker tooling, you will see the container just like a regular container. But if you want to see what we have really done is we have launched that workload. It's a bit dense, but this is the entire command line that we give to QEMU. So we actually launch it with a custom, highly optimized, small footprint, minimal TCP QEMU. Each container actually runs with its own kernel. We package a pretty recent version of the Linux kernel, and it has a minimal OS that is used to bootstrap the container. One thing I want to highlight is both the kernel that we ship as well as the minimal OS that we ship is customizable, and if you are interested in replacing it, it can be replaced. And you can do that one of two ways. We provide you tools to do that, or we have also done some integration with Docker's Linux kit, where you can use the Linux kit to build this kernel and this OS. So that if you like to add more options to that kernel, or you want to use a more recent kernel or an older kernel, or you've got some specific patches to the kernel that your application depends on, you can add them to this kernel, rebuild it, and you can install that kernel in lieu of ours. So that just goes to show you how fast Clear containers are. So now, what does it mean to say you're a Docker data center customer, right? For you, it's transparent. You use all of Docker's tooling. We just replace one component of the stack, which is called the runtime. And all that does is the default runtime on a set of machines it can be set to Clear containers. And then when you do a higher level orchestration, if you do some kind of node level tagging, you can say that, you know what, if this is a workload I don't trust, now launch it on this machine where the default runtime is Clear containers. Now, seamlessly on the same swarm, you can run some Clear containers, some namespace containers. But the rest of the tooling is completely transparent. So this is just a next level detail on what really happens when you launch a Clear container. Docker talks to containerd, containerd talks to containerd shim. And containerd shim talks to something we call a per process shim that we create. That is just a representation of the process on the host side, so that you can interact with it just like you would do with a regular container. You can get it standard in, standard out, get its logs, send it signals, get its termination codes, etc. So you interact with shim, which forwards anything, all your interactions into the VM. So we have an agent running in each virtual machine that interacts with the actual workload that's running inside the virtual machine. And the overlay file system and the Docker volumes are mounted transparently using plan 9 file system into the virtual machine. So that's why we support any and all volume plugins. You don't need to create special volume plugins if you want to run Clear containers. You just use the ones that you're already used to. The same goes for CNM plugins, except a couple of them that don't work, which is IPVLAN and Mac VLAN, but all the remaining plugins work transparently. So, okay, so all of this stuff works. So what are the challenges in the future work that we're doing, right? Some of the challenges is all of the container networking plugins assume that all runtimes are namespace-based runtimes. But with very minor modifications, you can make them support both VM-based runtimes as well as namespace runtimes. So we have pull requests both in CNM and CNI to kind of to allow plugins to support VM-based runtime so that you get a lower latency and jitter. Because right now, because we do one level of translation of networking traffic through the Linux bridge, we add a little bit of latency and jitter that can go away once the plugins start supporting VM-based runtimes natively. We have some issues with how the Docker swarm's internal DNS and load balancing works, because the libnetwork inserts firewall rules and IPVS rules inside of the container namespace, some of which we can translate to be applied inside of the virtual machine, but some we can't. In the near future, the few features that we're planning to add is, right now we integrate with Dockerd. In the future, we'll support integration with Containerd directly. Containerd today also supports multiple runtimes, so it's just, for us, we need to move the point where we integrate from Dockerd to Containerd. As I mentioned, today you can replace the kernel that we supply with a kernel that you build using the Docker Moby Linux kit. We also plan to add functionality so that we can replace the minimal runtime that we also have in there. And today, when you want to install Clear containers, you need to install a package. We have packages for Debian, Fedora, Ubuntu, CentOS, etc. But still, it's a manual install of clear containers on any given host. But today, Docker supports installing plugins for network and volume plugins. So we are planning to extend that to also support a runtime plugin so that you can install runtimes also using your Docker tooling versus installing using your distribution specific package installer. So in terms of how Clear Containers integrates with the ecosystem, we support Docker version starting on 12.1 all the way to the latest one. We do support Kubernetes 1.5 onwards. We also support CoreOS's Rocket implementation. So we want to plug into any and all container orchestration frameworks. And we are not linked to any particular distribution. Today, we provide packages for Fedora, Ubuntu, CoreOS, CentOS, and Clear Linux. But this is just the places where we provide packages. But there is not much dependency on the host system. We are self-contained, so we can support any Linux-based. Sorry for that. Linux-based host that you want. Same thing with standards. Today, all the standards assume that all containers are namespace-based containers. We are working both upstream and downstream with CRIO, AppC, CNI, CNM to introduce a notion of VM-based runtimes. So if you want to try us out, you can. The entire project is fully open source. You can get it from GitHub. And if you want to try us out very quickly, let's say you don't even want to install Clear Containers on your system, we provide a container that can run Clear Containers. So all you need to do is download a container, run that in privileged mode, and that has got Clear Containers runtime installed inside the container. So you can try it out even without modifying your host system. So without any pain, within a couple of minutes, you can try Clear Containers on any Linux system that you have. So as I mentioned, this whole project is fully open source. We are open to contributions, and we are also on IRC. Yeah, that's all I had. So any questions? I don't know how much time I have. Yeah, maybe 2 questions, yes.
Hi, quick question. You said it's an OCI compatible runtime?
Yes.
So does that mean if somebody's not using Docker but rather is generating an OCI JSON,
it works fine.
Then we can hand the same JSON to your runtime?
Yes.
Yeah, okay, great. And I didn't quite understand what the status of the bridge networking, if we were using
so we use, we support all networking except MAC VLAN and IP VLAN. That's because today we use a Linux bridge to connect the container network to the VM network internally. But once we get some changes upstream in the CNI specification and the CNI specs, we wouldn't want that bridge. That doesn't add any value. It's just a way for us to seamlessly work with any network plugin that you want to use. Yes.
So vSphere containers as well as vSphere integrated containers and Hyper-V containers, they're somewhat similar to?
Yes, similar. I mean, we have certain differences, but
yeah, could you elaborate what the differences are?
So, all I know about the containers from Microsoft is what I heard in the session, so I wouldn't want to speculate. I heard of Wix. Wix is very similar to ours. But in their case, I don't think they can. Again, I don't want to speculate what they can and cannot do. Our whole thing is we seamlessly integrate with the current ecosystem. We don't need to choose someone else's vertical stack.
Yeah, and yours are free, which is pretty good.
Maybe I misheard you. Did you say that you don't support VXLAN or MAC VLAN?
No. We don't support MAC VLAN and IP VLAN. That's only today.
Okay.
So we have patches to support them, but they're not integrated into CNI or CNM. It is not that you cannot be supported, it's just that it's not supported as part of a standard install from some distro.
So as of today, the default overlay network will work with?
Will work, yeah. The Docker Swarm overlay network works. You can try Contiv, we have tried Contiv, and a few others.
I have one more question. Do we need a Linux host to run these containers?
Yes, because we use KVM.
Okay.
So the solution is only for Linux at this point of time.
But are there plans to make it more of a virtual or a bare metal kind of?
We can take that question offline, sure. But we are part of the open source technology center. So yeah, you can talk to Amy. Yeah.
Thank you.
Yeah. Probably the last question, yes.
I'll make it two questions then, two quick ones. You mentioned Kubernetes. Is there a way to have an end-to-end mapping, like a pod thing?
Yes, so when you launch a pod in Kubernetes, starting with Kubernetes 1.5, we support the CRI spec, which means that we create a virtual machine for the whole pod. So if the pod is composed of 4 or 5 other containers, they get launched in a single VM. And that is necessary because when there is a pod, there's an expectation that the local network is accessible across containers, shared memory is accessible, and the only way to achieve that is to put them all in the same virtual machine. But in the Kubernetes pod spec, there is also security constraints for each container. We do support that by inside of the virtual machine, they are further containerized. So it preserves the pod semantics.
Okay, cool, thanks. Is hyperstart the same as for runv? Is that the same hyperstart?
We share the same code base. So we decided to use the same component and the same communication protocol from outside to the inside. So the rest of the software stack is different, but that agent is this common agent that's running the VM.
Okay, thanks.
Hi. Regarding the Kubernetes integration, do you have any limitations about the functionalities like port forwarding and things like this? Does it work seamlessly?
Not that I know of. Because in Kubernetes, all the port forwarding, etc., happens on the host side. So that is transparent to us.
Okay, cool. So NCNI works.
So I mean, I've tested kubedns, I've tested the default on layer 3 load balancer, service IP, all of that works. But I don't know what doesn't work, but we haven't seen anything. Yeah, thanks.
Okay. 那现在是下层要到这个3.4处。来，你看吧，对不对？ Thank you. So this presentation is on Kubernetes. How many people have heard of Kubernetes out there? Fair amount. So the original title was a little obscured, mainly to get it through. So who are we? I'm Matt Baldwin. I'm one of the co-founders of a company called StackPoint Cloud. We're a Kubernetes and DevOps company, and it's really easy to describe what we do. So what we do is we try to simplify the adoption and management of Kubernetes for developers and operators. And we try to take a very turnkey approach to that. And through our application, what we've done is we have over 3,500 organizations registered and using the application to build and manage Kubernetes clusters. As of last week, we broke 4,000 Kubernetes clusters were built. We built 4,000 clusters in the last year. To kind of put some color around that, we're seeing 17 clusters built a day, and all those clusters are moving into being managed as well. A year ago, we saw kind of an interesting trend where people would spin up clusters, they'd kick the tires with Kubernetes, and then they'd destroy the cluster. So high clusters, high churn of clusters. And over the last 12 months, what we've been starting to see are people keeping those clusters online and starting to ship their applications into those clusters. We try to take an approach where we believe developers and operators need to both be treated as first-class citizens. So the operator features need to be as easy, so simple that a developer can use those features. And I'll get to that here in a second. So the other people that we're working with on this is 101 Internet. So they're one of the world's largest hosting providers. They're a German-based company. They have a variety of portfolio of services, things from domain registration all the way up to web hosting. And now they also have cloud compute. They have over 70,000 machines distributed globally. Across that infrastructure, they have millions upon millions of websites. And that's all across 7 global data centers. And that infrastructure is obviously distributed. So why are we kind of here today? So when we launched a year ago to date at CoreOS Fest 2016, and since then we've been iterating on the product and kind of just moving it through the pipe of build to manage. And through that we struck up a conversation with 101, and since then they have branded the product as their own. So it's a white label offering. There's still ours is there. So basically users still have access to all the items that we've dropped into our own application, things like Linkerd, things like HE proxy, Sysdig, Fabric 8. Everything's vanilla Kubernetes as well. We pull from upstream. So we don't actually believe in any type of separate distribution of Kubernetes. We believe that it should all be from upstream. The other cool thing is these are free Kubernetes clusters. So all the compute resources are free along with everything. So the management control plane, Kubernetes, the virtual machines are all free. If you want to try out Kubernetes, it's a really good time to do it. So why Docker and Kubernetes? So without Docker, some cool things happened in the last 3 or 4 years. Docker and then Kubernetes. Docker was a really great way and drove the developer story quite well, but it didn't have a really good production story until Kubernetes came around. And then with Kubernetes and Docker together, we've got some serious disruption now. And using Kubernetes doesn't preclude you from being able to use all of your existing Docker tooling. You can still use Docker Compose, you can still use your tooling and just ship into Kubernetes. So with that, I'm going to kind of take you into production. So I'm going to jump into some demos. So there's a variety of ways to ship into Kubernetes. Through our application, we provide you a couple options, things like GitLab. That's pre-installed, pre-set up, and ready to go once you just add it into the environment. Another way is the ability to import Docker Compose files quickly and then have those packaged as a solution so that you can store them and reuse them on any cluster. So let me go ahead and jump over to all right, so this is is that big enough? There we go. There. So if I was a developer and I already have a cluster online, if I wanted to add a cluster, it's as easy as, well, the beta is limited to one cluster. I'll show that here in a second though. So if I wanted to add a solution, I have a Docker Compose file, I need to be able to migrate into Kubernetes. I can either go here. Oh, do I have internet? Give me a moment to jump on the Wi-Fi. Sorry. Cool. So we allow you to pre-install a few solutions. We have HA proxy, which is that's a native implementation of HA proxy wrapped up as an ingress controller and shipped with every single cluster. There's an autoscaler, and what that is, that's a node autoscaler, and I'll dive into that here in a second. And what that does is that basically allows your cluster to scale, add nodes and remove nodes as load goes up and down. Lastly, we also have Sysdig in here, so you could just easily jump into Sysdig if you wanted to. But my goal right now is to drop a solution in. So if I wanted to use a pre-existing solution, I can choose from any of these ones here. And those are all they're not just vanilla solutions that just get dropped in. They're also pre-configured and, configured once they're dropped into the environment. So you actually have a running thing at the end. If you want to drop in your own solution, what we allow you to do is just go and add a solution, go and take a Docker Compose file, drop it in, and then we allow you to name the solution, so we'll just use the hyphenated one. We have a concept of workspaces, and what this is a workspace is a place to collaborate on clusters and solutions. And so you can have a team have access to, say, production site number 1. I can say, go ahead and import this application and make it so only users of production site number 1 are able to actually use that application in their clusters. So I go through and I go, oh, cool, I'm going to go ahead and convert this. And there's an error. So I'm able to add it. If I want to save it again, save the source, and then what we're doing behind the scenes is we're scanning it, checking for errors. And then, once it passes, you're able to review the manifest. So now what we've done is we've taken it, we packaged it, and we stored it in our system so that you can actually take that application and then reuse it with any new cluster or any existing cluster. And we've also converted it into a Kubernetes manifest right here. Now, if you wanted to, if this was a brand new app and you're going to push it into a brand new cluster, you can say create a cluster, and then you go through the flow. So I'm going to choose site 1. etcd runs in a highly available setup. It's actually using the etcd operator. So that's HA, multi-master, multi-AZ. Multi-master's there as well. Multi-AZ is not there at the moment. As you can see, HA proxy gets dropped in. But I want to go ahead and add my own solution. And then all I would have to do is click submit, and it would begin to build the cluster, stand up HA proxy, configure it, stand up etcd, configure it to be HA, and then drop the solution in and set that up. We default to 1.6.1, which is the latest cut of Kubernetes. We also allow you to choose previous versions just in case. And that'll come into play here in a second. So that's the way you onboard, at least within our application, to be able to onboard into Kubernetes. So now that your application's in there, let me go to scaling. So now that you have your app in there, you want to be able to scale it, right? And there's a few ways that there's some various ways that Kubernetes is able to scale things. One of the basic concepts is replica sets. You can have a replica set that you say, I want 3 pods, and those 3 pods live across one. So if you have 3 nodes, you have 3 pods, 1 pod per node. And that's what replica set would do. However, if you see load, that replica set will always stay at 3, regardless of how much load you're getting. So there's another thing that can come into play. What this is called, and what that's called is a horizontal pod autoscaler. And what that does is you're able to configure an autoscale, horizontal pod autoscaling for a particular deployment that goes into Kubernetes. And you're able to set the minimum number of pods that you need online at all times, and you're able to set the max number of pods. And then you can also set limiters like CPU restriction, memory restrictions. So I'm going to demo some of that here, hopefully. All right. So I don't type very well in front of people. So as you can see, I have 3 nodes online right now. Now time for my cheat sheet, sorry. Here I've got pods. This is inside of of our own StackPoint namespace. Can you make it bigger, please? Yep. How's that? One more. How's that? Cool. All right. So we have in our namespace, we drop in the autoscaler, and so the autoscaler is how that's working in the background is it's going to communicate with the cloud provider API. The species balancer, that's actually the HA proxy ingress controller, and then the 3 systigs agents are pods, but those are actually deployed as daemon sets. And what a daemon set is a way of saying, I need this pod to run on all nodes at all times. So you would use it for something like an agent. So first, I'm going to have to create an app. And this is a really poorly written app that calculates pi very badly. And what I just did was I created a service called pi. I created a deployment called pi. If I go back into the application, I'm able to go and, does everybody know what the Kubernetes dashboard is by chance? Anyone seen that? So part of the Kubernetes project has a dashboard that ships with that project. By default, it's all set up over non-SSL. So what we've done is we tunnel it through SSL, and so we're actually able to serve the dashboard up immediately through our UI. So here you're able to actually just browse around. You can see your pi deployment. You can see I have a replica set, and then you can see that I have a single pod, and then everything is online. Now, step 2. Now I'm going to go ahead and create a horizontal pod autoscaler. And first, I'm going to go grab a list of horizontal pod autoscalers. There are none in there. So now I'm going to go create one for pi. And so that just created a horizontal pod autoscaler. I should be able to go and get it again. I should be able to describe it. And you'll see that I have a target CPU utilization, I have a current utilization, min replicas, max replicas, and then various events as well. So that just created the horizontal pod autoscaler. And now I'll need to create a server. I need to now expose my service to the public internet. And to do that, I'm going to do this. So that just created an ingress inside of Kubernetes. If I wanted to go and look at that, I'd be able to go into here, dive into it here, and there's my ingress. So with everything online, I should be able to grab it from here too. As you can see, I have, host is that. I use zip.io for DNS, for host names. And as you can see, it's kind of, it's the service working right there. Not super fast, not super slow. Now let's cause problems. Okay. Now I'm going to run Apache Bench here. And this is what sucks about demos. All right, at any rate, what would happen is, what you'd start to see is, as CPU utilization begins to climb, Kubernetes is going to start to add more and more pods. So what would start to happen is you'd start to see pending pods, containers coming up, pods coming online, up until Kubernetes hits a resource limit. When it hits that resource limit, what it's going to do is it's going to say, I need to start adding nodes to my environment. Let's go out and talk to like a cloud API, or you can do this with VMware as well. But what I do is say, give me a node, I need to add a node into the environment to handle more load. Node comes in, node gets built, node has Kubernetes stood up on it, and then Kubernetes emits it into the cluster, and then the scheduler is able to start to schedule pods across to it. And then once load dissipates, all that gets reversed. You start to remove the nodes that you added. Kubernetes does not, the autoscaler won't remove the base nodes that you started out with. So if you started with 3 nodes in the environment, those are always treated as reserved nodes since they're running master components and things like that. And lastly, the last thing I'm going to show you guys is, so how many of you guys are familiar, how many here have upgraded Kubernetes? Is it hard or easy? Like, sucks most of the time. There's a lot of guidance around upgrading right now. There's a lot of problems in upgrading. There's not, until now, no one's given a really good solution to this. So what we allow you to do is, there's not much to this demo actually. It's one button click upgrade. Now I want to upgrade to v1.6.1. Hopefully nothing blows up. And then we just start to upgrade the cluster. And we're able to watch the logs as we begin to do a rolling upgrade across the Kubernetes cluster while keeping your application, all your other containers stay online during this process. So that's everything that I have. If you have any questions, you can hit us on Slack here. Also, there is a giveaway at booth G20 where 101's giving away a free Death Star, the little Lego kind, not the big one. You can hit me at Baldwin Matthew. Happy to chat afterwards. That's everything.